Oh, what a disaster. It's like I got sabotaged right at the beginning of the show. Had to restart everybody. Just click on the links again and we'll get the show on the road. Mike, if you want to jump back on, everybody who was on before, please jump back on. I apologize. I had a lot of, I know it's crazy. It's like I got hijacked again. So if you want to join the show, join in. I'm going to start the show again. Hopefully this time it won't screw up. Mike, everybody join in. Click on the link again. Here, I'll put the invite link in the private chat. Or not in the private chat, but in the regular chat. Okay. That link is coming. Okay, it's posted in the live chat, everyone, if you want to jump back on who was on. Obviously, we had a couple of new people. I'm going to start the show. Okay, Mike's here.
A couple of new people.
Okay. Hey, Mike, sorry about that. I got hot. Your background noise is really bad.
Sorry.
Okay. Hey, Mike.
There you go. Hey, Mike.
Yeah, I'm going to start the show. I had two other people join it. I haven't seen them before, but I'm just going to start the show again. If you want to join, the link is in the live chat. And let's do this. Let's try this again. See if I don't get hijacked with my audio. All right. Hey everybody, welcome back. Again, I got hijacked right at the beginning of the show again. This time it was my audio. Last week was my internet connection is just, I don't know. Hey Mike, how's it going? How's your week?
Hey, Mike. Good. How you doing?
Pretty good. Busy. Got a lot of stuff on the go. Been doing a lot of research on a couple of inventors that have come and gone, and finding out some interesting physics on Floyd's suite. I've been kind of investigating his machine. Is that your background?
Wait, Sweet's machine? Yes, sir.
Yeah, the VTA. Yeah, the
Yeah,
VTA.
you got three.
It's the
You got
vacuum
three coils
triode.
wrapped around it.
It's actually two. The original device was two, so it kind of looked like this kind of thing, but one was basically what created the signal, and the other one would pick up the flux. Now, there was also two very large, they were called, well, they were speaker magnets. They're very specific for his actual design. They're 4 inches by 3 inches long, I believe, or sorry, 4 by 6. We have another person coming in. I'll let her log in here in a second. Welcome to the show.
Hey, Mike. And Mike.
Hey, guys.
Hey, how are you? Well, it's Friday night. It's open lines. We're just talking about Floyd Sweet's VTA. Whereabouts are you, in the States or are you in Europe?
Yeah, in California. I'm in California, near
Oh,
LA.
you're. Oh, okay, cool. Yeah, I'm in Toronto.
Yeah, yeah, I know.
Yeah.
We've talked before. You just have to stretch your memory. I know you do a lot, so I haven't talked to you for like months, but I made some of the
Yeah,
zinc,
you're on
the
Verdict.
graphite batteries, and I posted up some pictures of that. And
Oh, right.
way back years ago,
Yeah,
I started out making like Newman motors with Bedini circuits in them. That was my first like getting my toe in the water with
yeah,
building circuits, you know. And I'm colorblind, and I was
yeah.
told when I was in the army they wouldn't let me be an electrician. I wanted to be an electrician. They were like, no, you're colorblind, you can't do that. So then on my own, you know, just I was living in China, and they have these huge pavilions with electronic components and batteries and everything you could need, right, to build whatever you want to build. So I just started experimenting, and I made like 3 iterations of this Newman motor, and by the third iteration, it was my mind was being blown because it 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 was the running battery was oscillating, and I kept throwing dead batteries on it, and it would charge batteries all the way up, and I would throw and the charging voltage
Yeah.
would just get down to a certain point, and then it would be drawing power, and it would get it up to a certain point, and it did this for like 3 days, and I was living in the same room with the
Yeah.
motor, and the energy it put off was
Right.
pretty. There was like a lot of external whatever radiation from the motor. So after 3 days, my mind was blown. My body was like,
Did
I
you
was like in a state, and I just said,
energized?
I guess it worked. And then somebody basically
Did
made my unit, and they did it with capacitors. Like they copied my circuit and they put a capacitor in it, and they got it running with just a super cap. So I
right
don't know. Like
now?
I was,
Question.
yep,
Yeah, question for you.
yeah,
Did the motor make you feel better, like physically better? Like, did you find you a lot more
yeah. I felt
alert?
fine. I
Your
felt
energy
fine.
level kind of like you had like.
Yeah, I couldn't sleep. Like I would sleep for real short periods of time, and
Yeah, because
then to
like,
me,
yeah,
what
I get like this.
I was going through. My mind was being blown because I was a complete amateur. I was getting some guidance from people online who were more advanced than me, and I was following like that Newman. First, I was following the. I put a Newman with a Bedini circuit on it, and then I used a couple capacitors for tanks, and then I was working first with a the like the brush, like the contact, and then I switched over to a reed switch,
Yep.
and I got videos of it, and basically something else that happened is when I got the right capacitors, in it, the motor sang, like it chirped almost like a bird, and and that's when it was doing
Yep.
the shit, when it was really doing it. It made this real kind of like harmonic
Yeah.
chirping sound.
Hey, can
And
I
then
comment on that
yeah,
that whole thing with capacitors and
Yeah.
and I want to bring in a topic of room temperature superconductivity. Why is it such a complicated thing to understand that when you're resonating a coil, that it can also be a room temperature superconductor? I
right.
mean, because of the resonance, you know.
Yeah,
It'll act like one. It won't be one, but it will perform like.
Right. I mean, when I first was going through it, I was blowing things up from heat.
I mean, that's tying back to you and your matching your capacitor value to your motor. You managed
Right.
to get the right value to get it to sing like that.
Right. And then the heat was gone. I no longer blew
That's a
any of the.
tank circuit. That's a
Yeah.
tank circuit basically.
Yeah.
So that's how you create resonance with a coil is with a tank circuit.
Yeah.
You size your capacitor and your inductor just the right size between the two components, and you have a resonant circuit.
Yeah.
And why is that not a superconductor on its own to some level? I mean,
Well,
it's definitely
it probably
conducting.
is, but because of the way that they teach the science of electrical engineering, that's not language. We don't talk about it like that because that's what it is, but it shouldn't exist. It these things go against the when I try to talk to most electricians about this, they don't believe it happened. And I'm not an electrician, so I can't talk about the deep science of it. Well, I'm a.
Could I say so?
Yeah.
Yeah, could I say something? I had the same experiences. What you have to do, well, way I did it, and it sounds like you did it the same way, is you go in with a non-bias. Okay, you don't know what to expect, and if you're gonna have any effects at all, you just build it and observe what's going on. Obviously, in early years of doing this, I started seeing weird stuff. Like I was starting to see what I'm working a bit for myself, and I think that's really significant when you start to see it for yourself and try different things and see how the effects influence the performance of the motor. And then in the later years of working on the Renegade device, I started seeing health benefits. Like I was putting my piezo transducers up to my knee, which I get arthritis pain, quite often. And I would put it up and just let it rest on my knee for about 10 to 15 minutes. And then the pain's gone for the next 6 months. So explain that one to me. You know what I mean? Like you kind of grow with the motor as you're developing it and making changes and trying new experiments and seeing the effects.
Well, it could be, a lot of our
and that's how
pains
you innovate. That's how you
iron.
Well, definitely,
it could be a number of things, but as soon as I put the transducer up to my knee for about 15 minutes, and it was in a.
I mean, consider your knee has deposited iron in
Yeah, go
there.
ahead.
By pulsing your EMF around there, you loosen up that stagnant iron in the blood. Blood has iron.
Yep.
So
right.
Same thing with zinc.
It could be
will
it could be a
keep the
number of
iron.
things, but all
Zinc,
I know is
zinc will prevent the iron from rusting. The iron in your blood. So zinc will, like galvanized steel, doesn't rust because it has zinc in it. So you can keep the
I
iron
think
in
it's
your
the
blood
electrical
from
properties.
oxidizing. That too, but zinc also has electrical.
Yeah, like Tesla was working on a lot of the. See, Tesla knew this a long time ago, and he built this device that used a vacuum tube, and it kind of looked a bit like the plasma ball that we have today. And the only guy that I know of that has an original Tesla electrostatic healing device is John Hutchison, and I actually seen it work, and it does work. Now, those devices were pulled off the market around the early 1930s because the FDA said, no, we got to sell our pharma. So we could go off on a tangent on that one, but Tesla was right on top of some of the health benefits of his electricity, right?
Right. Well, I've for a long time I was in a factory injury. I injured myself in a factory when I was 24, ruptured my back, and they did surgery which failed. So I started, like, at that point early in my life, looking at alternative types of healing and explored a lot of things. And, consequentially, I don't look the age of my peers. People that are my age look much older than me. And I did a lot of things with, like, growth hormone, you know, earlier in my life. At the point when the growth hormone starts to get depleted, I was taking GHB for that benefit because I understood the mechanism of GHB, which in my opinion is why they made it illegal, is because they were about to launch HGH onto the market for a lot of money. And it's like a simple thing that anybody could do in their kitchen to make GHB. And it is converted, after you take it, it's converted into HGH in your sleep. That's why a lot of people that were bodybuilders were taking GHB. And you get that, like, relaxed, you get a compressed REM sleep after you take GHB. So in like 4 hours, you get almost the same amount of REM as you get in a whole 8-hour period of sleep. So, but those kinds of things, and working with, like, the Rife machine,
Yeah.
and
I was
I
doing
had a
that with
Rife
the water. I was doing that with the structured water.
and structured water, and just working with plants and animals. That's sort of part of my practice, is to have plants and animals in my life that I am in connection with, caregiving that.
And that's true. Yeah.
My
Naturally
picture.
as humans, we are connected with nature, and the animals are
Absolutely.
connected with nature. That's so. The thing
Absolutely.
is,
That's just,
our the way the way our evolution has gone, we've kind of disconnected ourselves from that in many ways. Versus,
yeah, I don't
the way
think
we
we
were, say,
necessarily
200 years ago.
yeah, I think we've been guided away from our connections to
Well, we basically
nature.
evolved out of the animal kingdom, and then that was the first step of evolution, to evolve away from the animals and not behave like animals. That's the first step of our evolution, is to leave the animal kingdom behind
Yeah,
and
but I
become
mean,
humans. Separate ourselves from the animals. We're not animals.
right. But I mean, when you say that we don't behave like animals, there's a lot of animals that if you observe
That's
them,
true, but in the
they're
end, those same animals, they do things that humans are not allowed to do. Okay,
right.
like they eat their own kids and shit. Come on, cats and dogs.
Yeah.
They're
Lizards.
animals. All the animals will prey upon other,
Yeah.
animals. That's why we evolved past the animal stage, and then the sciences came and all the higher intelligences. But the first step was to leave the animals, to
But
separate ourselves from the animal kingdom, and get out of the tree and stand up on two legs and become the dominant creature of Earth. Not be the prey and be the I don't know, the alpha predator or whatever you want to call it. It's unfortunate, but that's
animals are
Earth.
very connected to.
I mean, your own dog.
The animals
You
are
don't
very
if you
connected.
go you don't go underneath your dog. Your dog will bite you if you do that. Okay. You are on top of your dog. You control your dog.
Mm-hmm.
And you know that if you let your dog control you, it's only a matter of time before your dog's just biting you out for no reason, just because he's the boss and you're not.
My animals on the screen.
What I find
It's
really interesting
over
about
Unity.
animals and their connection with
Well, because you're taller than them, you don't have to work so hard. Yeah, they don't stand on two legs. If they did, the question arises: would you be getting along so well as you do today with, a gorilla? As long as it stays
guys,
on,
can you
keeps its
hear
hands on
me
the ground.
okay?
Yeah,
Yeah,
you're
you're
fine
good.
now.
As soon as a gorilla stands on 2 feet,
Yeah,
all of a sudden you
I
find
was
them
just going to
threatening
say that,
because
another
now you're
I was going to
skipping
say,
out there.
animals, the way
There
they're
you go.
connected to the earth is really interesting. You know, as far as like how birds navigate and how certain animals, like say, like a cow, he will only eat facing due north, which I found really interesting. Why would a cow
That is so
always
strange.
face north when he's eating?
You
That
mentioned that
is the
before.
oddest
I've
thing I
never heard
ever
that
heard,
before.
but it's true.
That is
Yeah,
so
and
weird.
the way carrier pigeons, how they navigate. My grandfather, when I was a kid, he used to raise carrier pigeons. So he used to drive from Niagara Falls to Toronto, and he brought two birds with him in a cage, put them in the back window of the car, drove 100 kilometers from Niagara Falls to Toronto, spend the day with us, and then just before he left, he let the two carrier pigeons go. By the time he drove back to Niagara Falls, those two pigeons were on his front doorstep waiting for him. They beat him home.
Wow, that's pretty cool.
And he knew it was them. He had tags on their legs. So,
I
yeah.
I was up in Oregon and I was in this town,
Like,
and
how do they navigate?
this town is famous in the 19 I remember the story. It was like in the late 70s or the early 80s. Some people from Oregon went on a trip to Florida, and their collie like got out. It was like a black, and it was, I don't know exactly, it wasn't quite a collie, but it got out in Florida and they couldn't find it, and they came all the way back to Oregon, and the thing made it all the way
Oh,
back
no
to the
way.
town. Yeah, and they got murals. It's up a picture of a mural of the dog, and
What?
I remember hearing the story. Yeah, so
Well, they got
that
really good noses, so they could have smelled their way back.
I don't know if they virtually left it all the way in Florida, if it
I
was somewhere,
mean,
but it was like, I think I remember seeing it was like over 1,000 miles. I know it was.
well, if you're a dog, you could smell the cooking, from for thousands of miles. You
It's
can tell by
magnet.
the
It has to
different.
be. They have to have, like, they must be able to read the ley lines. Seriously, they must have like serious, like, internal magnetic guidance
Right.
systems that we can't even comprehend.
Yes.
GPS. Yep.
Well, they do say that the animals have
Yeah.
more
Like
magnetite
yeah.
up here in their pineal
GPS in
than
the
we
head.
do.
Yeah.
It's called magnetite. They got magnetite up here.
Yeah.
That's what the thing is.
Yeah.
And we still have it, but
So
it's
your
less than
device,
skipping out
yeah,
there.
I'd like to hear more about your pulse motors, your Newman motor, and
Oh, I
your
put
Newman
one of the
motor. I'd
links
like to
up
hear more
there.
about.
You want to put can you run the thing up on
Yeah,
the,
I see that.
so that's the last, the one, the link I put up was the last version of it.
The old grid
Let's see if
system.
we got this here.
How do you
And
make
Just let
someone
me
a moderator in StreamYard? And Mike, how do you do
bear
that
with me here.
notification thing on YouTube?
YouTube
Yeah, how do you create
notification.
that?
What like sound? Yeah,
audio.
as you're just before you're posting it, it'll ask you if you want to
Okay.
it'll ask you if you want to set it as a premiere or if you want to set it for like say like 2 days down the road kind of thing. It'll ask you
Oh.
all those
Mm-hmm.
questions.
Gotcha.
See, let's see. I'm gonna share my screen here
You
for
want
a
to make me a
second.
moderator on the StreamYard? Or do you know how to do that?
The
Settings.
moderator. See, I only got the basic, so
Oh, that's the 250 a year plan or whatever.
yeah, I just no, I haven't. I'm just using the free plan right now.
I have the 250 a year plan. I don't know what that does. They lets you go like unlimited hours or whatever, but they have a few different plans, StreamYard.
Right. Okay, let's try to share this. See if it's coming up here. Okay, can you guys see
So how do you
this?
pronounce your name?
My name?
Yeah.
My name's Reed.
Okay, that's just your handle there?
Like weed. Yeah, yeah. Calistoga refried.
Okay, Reed. All right.
Yeah.
I was going to say,
Can
have
you
you
guys
ever
see
tried
my
to switch
screen?
with capacitors?
Have I tried to what?
You ever try using capacitors to do switching for you? I believe the Don Smith device does that. No? That's what I heard.
Yeah, I don't. My head's been out of it for so long, I can't remember
I
if I
heard that
did
about
any of
that.
that stuff. But
That's what I heard about. That's how he switches. He doesn't have any transistors. There's no
Can you guys
transistors.
see my screen right now?
yeah,
Yeah, I see the video.
it's kind of jerky, but bad frame rate. But it is what it is.
Yeah, like my Renegade is a cross between Newman motor, Robert Adams motor, and a Bendini motor. Kind of like all those concepts together as one, right?
Yeah, and like I was working
So
with
my big discovery was the transducers.
transducers.
Yeah, I was working with the transducers.
Yeah, I was looking at that's with the
Go
last
ahead.
motor you were making, right? One with the big rotor.
Yeah. Yeah. So the transducer really made a big difference
You
in
know,
my
Mike, you could
circuit.
probably switch with those transistors
So
too.
yeah,
Those
I've been working
transducers
with the
can be
trans.
switched.
The thing was is that
Yeah,
I
I've been
had
trying different models. Go ahead.
that motor I made with 12-volt input. I was getting over 80-volt peaks on the spikes, and so if you just step that up, that's a whole lot of power. That seems like it's a viable way to
Mhm.
manage household power. Even just get it up to like a couple
Yeah,
hundred
like I'm
volt
using kind
input.
of.
Yeah, you want to turn off your video,
Yeah, because like
Mike.
my
Let me see.
Renegade right now, presently. Yeah, I shut. Yeah, I shut my video off for a second. My wife and daughter are running
Your
around
Wi-Fi.
here, so they don't want to be online. But
No, I'm saying your
what's that?
Wi-Fi
With the
signals.
Wi-Fi?
Your bandwidth is limited. You're on a Wi-Fi, right?
Yeah, I don't know. No, my bandwidth is fine. I've never had problems with it before. It's really weird. Really weird. But yeah, what I was saying is um, I've been experimenting with barium titanate and a couple other types of transducers, but it seems like the barium
Yeah.
titanate transducer is the best.
Yeah.
So
Have you ever tried using this transducer as a read, like a read or a switch?
never as a switch. No, I haven't done that. It's
You're
always
using it
in
as a
parallel with the
capacitor, right?
coil. Well, it's smoothing the back EMF spike and actually doing a phase shift of it. It
What's it?
basically what
It's helping you
I've
convert the
been
spike.
told. It smoothens it out. Yeah,
Helps you
it
convert it, right?
helps in the conversion. It also boosts the power up and also increases it. There's a 30% gain in the transducer.
Well, why
And
couldn't you
can
use
see
the
it visually
transducer
with
as
the
a
light.
switch,
Like
though?
the
I mean, it's
intensity of the light totally changes, right?
I'm
I'm
gonna
just
go
trying to
like
think how
this.
you would use that
There's
as a
lag, I think.
switch.
Yeah, lag.
Hey, did either one of
I'm
you
trying to
know
think what it'd
Mike?
be like as a switch.
Did either one of you know Mike that was the quantum magnetics guy?
Yeah. I know who you're talking about.
Yeah, he passed away.
The Quag Jet.
Yeah, he passed away
Yeah.
like a couple years ago.
How old
Right,
was he?
right at the beginning of COVID. He was not that old. He was in his, I want to say he was in his 60s. And man, I had been like trying to save enough to buy one of the kits,
The
and
QEG.
yeah, the QEG. I mean, and I finally got it together and I reached
Oh
out
yeah,
and
yes, yeah.
I
I know
found
who
out
you're
he
talking
passed
about.
on. And like I think all of his stuff is
Can't believe
pretty
that.
much gone. His I'm in touch. I'm like in touch with his daughter or something. She has like some of the plans and stuff that.
Well, I know how it's
But
built. Not
yeah, yeah,
per.
yeah. His stuff was
I know
really good.
the basic concept
His
behind it
plates,
is to ring the
but
steel.
yeah, but the only thing is the way he was making his graphene panels. He sort of had a thing that he developed, and I don't know.
I had no idea there was graphene involved in there. I thought it was all iron and
No,
coils and.
yeah, but as
Yep.
he developed, he actually created
Yep.
panels so it could run purely off of the panels and the super caps, and there was like a series of
Right.
panels, and it would just hit them and draw like it was like on a timer, so that it would just keep hitting the panels, and they would immediately bounce back, and they would have good amperage. Like one of these panels was like 12 by 12, and the thing had
Graphene panel.
Yeah.
To capture the spike or whatever.
No, they actually have a charge. Okay,
Oh.
it's like
Wait. Reed, let me slow you down here.
Yeah.
Was he ringing he was ringing the steel?
No,
There was a 4 chunks of steel, and he had another piece of steel coming really close but not touching.
No, this is a different. We're talking about two different guys.
Okay.
Let me look it up here.
The QEG, quantum energy generator.
No, I know who you're talking about.
No.
I know who you're talking about.
Yeah,
I know the device.
Quantum magnetics.
Okay, I'm mixed up then. I haven't seen this one.
Yeah.
Yeah.
Yeah. No, I know the guy you're talking about.
No, and he was very.
Yeah.
He actually
He had the 3
Bell
plates on it. They're made of carbon graphite.
Yeah. So I followed the guy for years, and finally I got
that
in touch with him.
explains it.
And I found out he was from my hometown. He grew up with like kids I knew, and then he worked for Bell Laboratories, and he worked in miniature power supplies, like on boards where they need like micro supplies of power.
Yeah.
He was into doing that kind of stuff. So then when he got out, he started doing this. So he had like a
So he
lot
went
of,
from micro to macro
Yeah,
power.
maybe.
basically.
yeah. But yeah, these panels were basically the power for the generator, and then you could basically offshoot that.
And this was a solid state device? Sounds like it.
Yeah,
No, it wasn't salt.
I can pull up his
Well, it's
link.
both. He had the rotor
It's
spinning.
both. Yeah, he had
and,
like a complex
yeah.
circuit to control it. Let me see if I got him in my subs. Hold on.
I gotta tell you, I mean, I'm gonna just go crazy if I find out all these devices are just operating off the flyback. I'm gonna go nuts here because it's looking like that. You know, even I think the Don Smith device, the Floyd Seat device,
Well, they're all related
these-
to a flyback.
this is all harnessing the flyback somehow.
Yep.
I mean, if you know, it's a great way to consolidate
Right.
your.
See, but the only thing different, Mike, with the Floyd
Yes.
Suite device, his device was a little different. He was able to get.
Oh, it
big
was, but it was
ferrite
flux. It was a
magnets
flux
to
device.
deflect.
The Floyd Seat device
Now-
was a flux device.
Well, there was a lot more to it than just that. His
But it was
his
focused on the
magnets
flux
were
and
special
shooting the
magnets.
flux out at the
And
blotched
he-
wall. You know.
Right. But he had a self-resonating magnet. So he would put like
Right.
like a
It-
Here it is.
a razor blade on top of the
It's
magnet.
yeah. The
and
barium
that
the barium
razor
would,
blade
would
start vibrating.
the barium would lose its. It wouldn't be able to hold a permanent magnetic field. It would keep changing because he would create holes in the barium.
Well, he did his
you know, not holes, but magnetic holes per se. Like by I think something like that was going on. He was depolarizing
when
sections
he
of
was-
the barium magnet in a way to manipulate the blotched wall. He was
Right.
trying to move the blotched wall off center, off balance, so that it would always try to find balance again. I think that's what was going on there. So his strategy was to debalance the magnet in a way where it would slowly try to come back into balance. And if you had it under a load, it would probably never reach balance
Yeah.
again. You know what I'm saying?
Integrated
By creating
power
That's the guy.
EMF
its
holes
own.
in the magnet.
I
It
know.
runs continuously
Can you hear that?
and doesn't require any electrical
Yeah.
or fuel input.
Oh, this
Yep.
is the
Usual?
quantum.
Yep.
Yeah.
That'd be a reasonable definition. Question number 2. What would the COP of such a machine be? Let's see. We've got rotary torque plus a little electrical output.
You got any schematics on this?
By
That's what I'm saying. I think she still has. I think we could
Input.
still. There's still
Infinity?
available schematics
Now,
to
how
build
about-
these.
how
Without that, it's pointless.
about,
to even look at this,
energy
you know?
accumulated over a 40 or 50 year period. Maybe
Great video and all, but without a
Yeah.
schematic, what's the
That doesn't
point?
do either. See my
Well,
point?
there was a lot of
Okay,
people
okay. I know
bought
some of you are
kits
gonna
and
say,
built
but
them,
your
so
power
they're
cells
out there.
are
There
your
was
input.
nobody was
No, I said
disproving
that
his
they're
work at
an
all.
integral part of the machine.
I'm just
It's a
critical when it comes to
fundamental
seeing stuff
piece of the machine
without a
itself.
schematic.
It's like saying, "Hey, I got a good
Yeah.
idea. Let's take the
Yeah.
coils
It's
out
like
and see how fast
what
it
do you
runs."
how are you supposed to
It's not going
you
to run
know
at all. All right, how about the
understand
magnets?
what they're
Let's pull
talking
them and
about?
see what kind of power it can deliver. Well, it's not going to do anything. Okay,
Yeah.
then let's take.
Well, that's what it is. Those are
It-
the panels that supply.
I think they're
The-
those plates. Yeah, if they're like a battery. they're a
graphene
battery.
panels. Well, that would be a permanent power
Basically, I
source
think
if you
that's
got
what they are.
graphene
Yeah.
panels.
Yeah, that's what he came up with.
Yeah.
This title of this video is the world's first self-powered Q beta prototype with silicone crystal graphite power cells.
No doubt, graphene is a great candidate for 100% capture of any type of radiant spike.
Well,
You can do 100% on
the way
that.
I see it, any kind of like perpetual system, I think is going to be a solid state. So I think the carbon graphite magnesium batteries that I've been working on, stuff like his, You know, I think that's the direction this is going to go in. If you can make a
I mean, at
battery
first
cell
glance,
that never dies, well, there you go. There,
at first
Yeah.
glance, what I see here is a graphene perpetual power source from just having graphene powering a pulse motor.
Yeah, he was also manufacturing rack mount graphene power sources, so like you could stack them up and
yeah, I've seen those.
power like music, you know, like be off grid and power amps
Yeah.
if you wanted to.
A lot of people don't know this, but graphene does maintain a certain level of voltage, even if you load it. It'll come back over and over
Right.
again. It's just
Right, like it's sort of like a springboard. What he was doing is if you drop it drops very quickly and it comes back very fast.
kind of like a lead acid battery.
So
but
the key
better.
is just like drawing from it from a moment and then
Right.
drawing from
Pulse.
another one. Right.
Like a super cap.
Oh, is that what he's doing?
It's like a
That's
super
what it's
Yeah,
cap.
it's like he's milking a cow.
right. He's staggering
Yep.
Yeah.
the draw, the loads.
It's beautiful,
plates.
man.
Yeah.
Like he was a genius.
smart.
And I hope he didn't
know,
get
that's-
taken out. You know, he
That's similar to how Nikola Tesla designed the three-phase generator, not motor. He staggered the peak of the sine wave into 3 sections to give you a steady peak.
Right, and if you
Three
think about
phases, 3 phases, steady
Right.
peak at the top.
and if you think about it, that could be key in any type of a battery setup where instead of using a battery,
Any type of system, what you
and
mean,
drawing your
DC or AC?
no,
That's
what I'm saying, instead of
keep your peak stable.
drawing
the pulse,
continuous,
the pulse
Listen to me
peaks.
for a
I mean,
minute.
you know,
instead of drawing continuous amperage from a pool, just ticking it,
Right.
tick, 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 tick,
Right.
tick, tick.
constant DC is in the garbage. Throw it away.
Yeah,
It's worthless. You're wasting energy. You don't want to constantly hold the positive and negative contacts down on your battery. It's a waste of power.
yeah.
Guys, I'm just going to step out for a brief second. Guys, just carry on with what you're doing. I'll be back in 5 minutes, just going for a quick smoke break.
And pulse the system. And
Yeah,
if you do that, if you pulse the system, you can take advantage of the reverse pulse that comes afterwards on the off cycle. And that's your other 50% of your efficiency. That's why all these motors only have less than 50% efficiency, because they're not using the flyback. They're only using the forward pulse
Yeah.
that the inductor
In
makes.
this video, I'm going to introduce an unusual new product, simply called Black Box.
And the Newman motor
How it can power our largest
was
experimental
using the flyback also. It was using it to
Turn
drive
large storage battery.
the rotor.
Just might want to
Right.
see this.
It wasn't driving the rotor with, I don't think he was driving his rotor with the forward pulse. That's a huge flywheel with a lot of weight.
Several months ago,
And he had a really high resistance coil. So he needed a really high voltage to get through that coil. And he had to keep his amps low to not burn out the coil or to damage whatever. And because you don't need amps to get, once you get through the coil with even a milliamp, that's all you need to create the flux in the coil, the milliamp to get through the whole coil. If you don't have enough volts, it's going to go halfway through the coil and not make it, and nothing's going to happen. No EMF field
Right.
generated.
So right-
yeah.
Right now, what he's talking about is these are basically boxes with these that
Is this
little.
still the quantum magnetic device?
Yeah, this is the same guy, and he made those little black boxes are basically boxes filled with the graphene plates, and then you could basically charge up a cell phone with it. and then when you disconnect it and allow it to sit, the energy just comes back up in it. There's no need
Right, because
to
the plates are so close together, the Kashmir effects are happening inside there.
right. So it basically is a perpetual,
Right.
charging device.
It's like two antennas so close together, they're catching little high frequencies that get caught in
Right.
there.
And he came up with some kind of a gel matrix. So the graphene is maybe suspended in the gel. Not exactly sure how he did it.
Would that interfere with the small signals bouncing around in there?
I don't know. Like that's been basically the
Probably
people,
not. Probably not, because
I-
these are not signals that are dependent on a
no,
certain type of medium to be,
right,
flowing.
they're radio, radio
If it's high frequency, it'll
signals.
probably go through any kind of medium.
Right. I mean, obviously, metal shielding and all that is an issue, but like gelatin could actually be beneficial.
Well, what I'm saying is if you take the energy from one of these graphene things to generate a pulse through a coil, then you take the flyback that happens after there and you send
Right.
it back into another graphene plate, and you're actually charging now.
Well, or that's that, or you don't need to do that. Then that's when you can start building up your tank of power. You can use these as this power source.
What I'm saying is, why build a tank when you could just charge one plate with the flyback pulse?
Yeah.
You could charge it up, because the flyback is going, the voltage that one plate's going to create, I don't know what it is, maybe 10, 20 volts. And then you send that through a coil and you create a spike that's in the hundreds of volts that can then charge another plate to a higher voltage.
Right.
I'm pretty sure he's doing that. If he's gotten this far.
He goes when he first developed the plate, he went into a pretty deep explanation.
Do you know if there's any transistors in his design or any
No,
coils?
I don't think so. And he uses maybe transistors when he uses the plates with the pulse motor, because it's
to drive the motor, but he's not taking the flyback from the coil on that motor. Huh?
Well, he is, but he's also using a timer, like a 855.
So he's dumping the flyback into a capacitor and then dumping it.
Yeah. He's got on that last video we watched, which was the
what I'm saying, instead of dumping the flyback into a capacitor, dump it straight into the graphene, because it's more receptive than the capacitor to such a high voltage. Unless these graphene batteries can't handle high voltage, then that's different.
Yeah, I don't think they can. I think they operate more at a lower voltage.
Oh, and put them in series. I would put them in series and get to that high voltage just for the sake of being able to spike it.
So he does. So I think that what he gets out of this setup, where there's like 6 plates here, I think he's getting something like 36 volts at a few amps.
If you want to get to 1,000-volt system on these plates, so you're looking at a pretty big device.
Right, but I mean, this is just basically
it'd be worth it though.
It's the size of the motor he made.
This motor, onto it.
The motor that he made, it's like optimal voltage is around 32 to 34 volts. So this basically provides.
Right. He designed it for a practical application of today.
Yeah, and basically this was an experimental project.
He was going for the money, trying to make some money.
Well, he actually was trying to sell these kits. He didn't really charge a lot of money for any of his stuff. He was more trying to promote people learning how to do this themselves. So most of his stuff he sold in kits. So yeah, I'll stop.
Oh, so he was selling it. He was selling it.
Yeah, he was. And like I said, I think that maybe the plans are still available. But I don't think any of the kits are still available.
He was making the graphene himself, or what?
Yeah, he was making those plates himself.
So he had an injection mold or something like that.
Must have. He lived down in Florida. I was really close to like heading down there, trying to get him to let me work with him.
I'm in Miami right now. I'm
Yeah.
in Florida my whole life.
Well, I think his
Anybody
family's still
knows
there.
how he died? Did
I think he had
anybody
like
knows
a.
how he passed away? Or
I got an email. I have to look in the email. His daughter kind of shared with me what happened, but it's been so long that I can't quite remember.
What was his name again?
His name was Mike as well.
Mike. His name was also Mike. Okay.
Yeah, it's funny, huh? The three Mike's-keteers.
The
Yeah,
Archangel Michael.
and it was really trippy because I was like a fanboy of his. I had been watching his work for like years because I was just getting in when I found him. And then when I finally got to the point where I emailed him and then we started to talk like more personally in email. Oh, dude, he grew up like a few miles away. He didn't go to the same school system. He went to the one that was like adjacent, but like my cousins went there and stuff. And it was trippy, that we were that
I keep
close.
saying it over and over again. It's a small world.
Yeah, it is.
I could tell you a story to prove it. Mike heard it once. It's got something to do with the Nazis. I don't know if you remember that story, Mike. But whatever. Yeah, it's a small world. That's all I'm saying.
Yeah.
Extremely small
is.
world.
it's a while ago, wasn't it?
What's that term?
I can't
Third degree of
remember offhand.
separation? Or whatever.
I've done so many shows. Oh, God.
I was talking with Magneticus. I don't know if you heard him. He's on YouTube. About the number 666. And
Well, I had
people
a
think
close
it's
call a couple weeks ago.
a close call. Like what? Close call what?
Yeah, I had that car accident 2 weeks ago.
Oh, that, yeah. You
Car
told me.
you
accident
did.
2 weeks ago I had.
Was everybody okay?
Yep. So, well, the girl that I hit, she got a bit of whiplash. I was okay. My car was okay. Her car was demolished. The whole back end was smashed in. It was we have roundabouts. They have them in
Oh,
England
yeah.
all over the place. Where I live.
Yeah, we have them here now, all the place
putting
now.
roundabouts all over the town where I live. Yeah. So, yeah, she decided to slam on her brakes when she entered, and I was behind her, checking my blind spot, and that's when I went into the back of her. So,
Yeah.
That's
I
some
came out
kind of
unscathed, but she got a
That's
little bit of
some kind
whiplash, and
I was going to say that's some kind of a world freaking conspiracy by the car insurance companies to just go, oh, hey, here's a good idea. Let's just put roundabouts now that people have
You're talking about the curves?
No, where instead of an intersection, now you come up and you
Oh,
and you
those
go around a
loops that they
circle.
put in, right?
Yeah,
Right.
you go around a circle and then you take a ride and then every
Yep.
together.
Yep.
It's
Yep.
basically built by insurance companies, I'm sure.
You know what I heard once about the insurance companies? That they are the ones controlling the weather.
Yeah, it's
because
That's
they don't want to pay out. They don't want to pay out. So when a
That
hurricane
too.
comes, they got the
they
system
squelch
to.
them. Yeah, it happens.
That's a theory, you know.
Well, it's
Like,
not.
why do these hurricanes all of a sudden, like?
Weather modulation is not a theory; it's a reality. They've been doing it; it's a real thing. So when they say it's a conspiracy, they're lying.
Yeah, but think about it.
Absolutely.
Who stands to benefit the most by funding such a project? The insurance companies.
And the military.
Well, probably the insurance companies, because they would have to pay out a lot of money if a hurricane. Okay,
Yeah,
let me
but
just tell you this. Have you heard of Hurricane Andrew?
Yeah.
Okay, I was in Miami Beach when that thing hit. I saw it. I was here for it. So when that thing hit, not a lot of people know, but I rented a 10-disc hurricane documentary from NOAA or Nova, and one of those discs of DVDs, there was an image of another hurricane that was going on the same time Andrew was hitting where I live here now in 1992. And this hurricane was covering the entire Atlantic Ocean, and it was moving about 280 miles an hour, or I think it was close to 300. It was the size of the Atlantic Ocean. If you were to see the coast from the European West Coast and the American East Coast, you had about maybe 50 miles, 100 miles before you entered this hurricane on either continent into the Atlantic. Just imagine. And I saw this with my own eyes, okay? And the Hurricane Andrew was the spin-off of this hurricane, just so you know. And it was top secret during Hurricane Andrew. So imagine if one of those hurricanes, that hurricane, it didn't have a name because they didn't publicize it. It would have created a panic. This thing was the size of the American continent. If it went over the American continent, it would cover the entire North American continent, some of Canada and some of Mexico. It was that big. It covered the entire Atlantic pretty much. I saw it with my own eyes on the NOVA hurricane documentary disc set. It's like 10 disc sets of DVDs from back in the early 2000s. They made it, and yeah, it was top secret at the time. They didn't release this data to 10 years later, and yeah, it's a reality. So if this hurricane went over America, imagine how much money the insurance companies would go broke.
Hey, Mike's here. No, we got Mike and Mike and Mike. Hey, Mike.
Yeah.
Hey, Mike's a time traveler, dude.
Two places.
How does that even work?
Oh, and they're out of
Trying
sync.
something. Bear with me.
How'd you even do that, Mike? That's your
It would-
Doppler.
No, it would be so funny though if, like, you know, you were live streaming, you know, and then a little while later you came in as a guest, and you know you'd have to get the timing stuff, but you can almost pull it off and mess with people for a minute. Be like, oh, who's this guy? I don't recognize the name, and then it'd be like, I'm you from the future. Have the video kind of jarred and stuff, and then it goes off.
So I don't understand why you can't, if you get just the right amount of current and voltage to pass through the right coil with a certain amount of impedance, and you don't push more amps or more volts, just what you need to get through that coil, that would be a resonant circuit, no? I mean, that's why you size the capacitor to hold just the right amount of joules to push through this coil.
Can you guys hear me
without
okay?
over pushing
Yeah.
the coil or under pushing the coil,
Right.
It's like a pressure.
Right, and there was something that was like the sweet spot about that circuit, so that when the running battery fell down, it opened up significantly more, because I was checking the voltage, and it was like the spikes that were coming into that were getting higher voltage as it got lower voltage, and then it went back to nothing again, practically.
I'm just doing
So-
a quick test here. Can you guys hear me okay?
Yeah, we hear you. You're less lagged now. Seems like no skipping.
Is it?
It's a lot clearer too.
So I kind of wanted to wonder if that oscillation wasn't an external thing, that there was.
What I
actually-
think is going on is the oscillation is just a frequency, but what's important is to not put more joules of current through this coil than you need to, and to have the just the right amount of voltage to push as minimal joules through, because then you don't have any heat going on. There's no reason for the coil to resist anything, because you're not pushing more electrons through it than it can handle as a coil with certain amount of copper mass to it. So by sizing the capacitor to hold just the right amount of joules per that coil and its mass, you see what I'm getting at?
Oh, right. And I'm saying, and so what I'm feeling that to scale,
And then the frequency is a different thing. That's a whole different thing there.
if
But
you want to scale up the power of that, you have to scale everything. You have to get all the wires need to be scaled as well. But I think that when you hit that sweet spot, then you can take note of everything.
so
And
you
then,
know the Bedini circuit,
yeah,
and that 100 ohm resistor on the base controls how long the duty cycle is, as in combination with the magnetic pass on your core, and that allows for only a certain amount of joules to enter that coil
right.
because it's shortening the duty cycle with the resistance on the base. It's if you lower the
Yeah.
resistance to the base, and then the duty cycle will be longer, and you'll be letting more electrons pass into that coil, therefore creating heat loss, because the coil has a set amount of resistance, and if you push too many electrons through there, that resistance is not going to change on that coil. So if you go past its ability to receive electrons, it's going to do impedance, and it's going to kick back and what it does anyway.
What if even if you get to the perfect sweet spot, you still have the oscillation? Because I'm just
Right.
saying maybe the oscillation is some other.
Well, the
way.
sweet spot is an oscillation, but it's a key frequency.
Yeah, but it's working with some. I'm saying I'm thinking about the law of conservation. Okay, and the thing that I picked up with looking at light and sound entrainment with the brain, right? So the brain will latch on to an external frequency that's almost the same because it saves energy by doing
Well,
that.
the coil is going to respond to a certain vibration as well, and that is that frequency.
Right.
So when you vibrate that coil a certain vibrational rate, you don't see it shaking, but the coil is moving.
Oh,
You can't
okay,
see it.
yeah. Yeah, so actually for every coil, for every frequency.
The coil gets
yeah.
pressurized. It gets pressurized outwards by your forward voltage. It pushes the coil out, but it's wrapped around, so it can't really go, out. But it's wrapped around, and so, but it does move so small of a distance you can't see it with your eye. But it is being pressurized when the switch is closed, and then when you remove the switch, that pressure it retracts again. It implodes.
It's the
So
dynamo.
that's the piezo effect. Right? That's the vibration.
The
That's
dynamo
happening. It's happening in coils too.
Yeah. Like in my
You can't see it, but it's happening. You can't hear it. Well, you can hear it sometimes if you have the magnet over or whatever. Sometimes
in my Renegade device, my transducer, I put it up to the scope, and it's saying that I'm getting a frequency around 42 kilocycles. So it's a hyper resonating my coil. And I found that I can achieve resonance in my coil the second I put that transducer into the circuit, and then I get a 30% power gain. And it's like night and day. You can, as soon as you turn it on, or if you put it like on a switching circuit, turn it on and off, it's like instantaneous change.
It's possible the same coil can be resonant at more than one frequency.
I think I got it resonating at a high frequency. Well, my scope's telling me about 42 kilocycles. So if my coil is 2.2 pounds, I'm putting in 49 volts DC, and with a transducer behind it, it's telling me I'm getting about 764 volts back EMF spikes with only less than 2 watts of input on the drive side. So that's pretty impressive numbers right there.
Do you know what the frequency, resonant frequency for barium is?
Barium titanate. Well,
Yeah.
these ones are this one's listed as
I mean, the
40.
metal itself. What is the resonant frequency for that particular metal, barium titan?
I would have to have it tested, but it is rated for 41 kilocycles at
Barium
40
titanate.
watt. Yeah,
That particular transducer is.
yeah, that particular model that I'm using, and you can it's readily available. You can get them on Amazon. I got the small little wafers that you can buy. They're about $15, $12, and just hook up your positive negative, just solder it, and hook it in parallel with the coil. So I got the disruptive discharge going through the transducer and the coil at the same
At the
time.
same time. What's
Instantaneous.
that doing though? That's
It's
taking
doing a
some of
shape.
the load
It's
off the coil, no?
taking, yeah, it's basically the input current goes to like into the milliamps. So my Renegade can run at 20 milliamps at 49 volts. So my batteries don't even see the pull off the battery. The battery basically is sitting there going, okay, I'm ready. But you're not really pulling it. It's running off pure potential, right? It's not running off of current like most motors do. It's running completely the opposite way of a standard motor. It's running off voltage potential, not current. And that's the key. If you got a big coil behind it, that's 2.2 pounds. Going back to the Newman theory, where you put high voltage into a very large inductor, okay, you're going to get electromotive force, a lot of it. The current's generated in the coil, not from the coil coming from the battery, because the disruptive discharge switch that I use eliminates that, and also eliminates to a great deal the lens effect. It's not a
What's your
factor.
disruptive discharge switch? Is that the spark gap
It
or
is-
is that the
Yeah, it's the
transducer?
12. It's the 12 volt single throw relay switch you can get from Canadian Tire.
Oh,
Like
okay.
$6.
An automotive relay. Okay.
Automotive relay switch right off the shelf. I just advanced the armature. I just kind of bend it forward a little bit just to advance it, and I could actually make that switch fire a lot quicker. And it's pretty robust. It can take a beating, so you can hammer like quite a bit of voltage. It's only rated for 12, but the thing is, it can handle 10 amps. But I'm only putting potential in. I'm not putting in amperage. So that's why my switches don't burn up. They don't get destroyed. Yeah, and like one of the guys that
Reeds go bad
All
real
of
easy too.
yeah, well, see, that's why I put a reed in basically an isolated circuit from the rest of the motor. A lot of people put their reed switches in the same circuit as the power circuit. You can't do that. I've blown up hundreds of friggin' reed switches. Like I could have a graveyard.
Can
full
you
of
explain to me how you isolate the reed here?
It's just a separate circuit. You just don't include it into the actual drive circuit. So I like to hook my my trigger switch and my relay to a separate battery source.
Oh, wait. You're
Just to
using the
make
reed.
sure.
You're using the reed to control the power to another switch.
Right. So I use the proximity sensor, okay, from a 3D printer, and I hook that in line with the relay switch. So when the magnet comes around, hits the proximity sensor closes, opens the circuit, closes the gap on the spark gap switch or the relay switch, and that's how it works. So I got those two components on
Oh, that's your
separate
isolation
circuits.
there, right?
That's the isolation.
The
Now the power
proximity
circuit,
sensor.
right, right. Exactly. So as long as you keep that trigger and the proximity sensor or Hall sensor or whatever you're using on a separate circuit, you'll never have to worry about it blowing up.
Blowing up a reader or a
So
transistor?
both,
Hmm.
both. Because if you put too much, like say like a transistor, if you're using a transistor, if you put too much voltage in through the gate, well, guess you just blew up your gate on your transistor, and your transistor will be
So you're
non-functional.
using the proximity sensor to get yourself a steady trigger.
That's right. And
I got you.
uninhibited, I don't have to worry about back surges.
Why would
I
the
don't.
why would the reed switch vary if you're giving it 12 volts? Why would because of the flyback is destroying it?
Yeah,
Right, the
the reed
flyback
switches
will,
blow up.
yeah,
Uh,
big time. And I blew up many. Trust me,
Yeah,
yeah,
me
yeah.
too.
many reed switches. I could start a
Okay,
graveyard.
can I say something about reactive power here and radiant energy
Well,
and
I think they're
radiance
one
and
and the
radiant
same.
spikes? Okay, radiant spike, right? Now, a lot of people want to dump the radiant spike into a capacitor, spend a couple minutes doing that, and then dump the capacitor somewhere else. But how is that keeping the reactive power reactive?
That's
You're removing by doing it
that's where
like
the
that.
transducer comes.
Well, what I'm saying is radiant energy is a reactive power. If you're going to select radiant energy over a period of a few minutes into a capacitor, you're right there. You just removed the reactive power by doing that. If you keep dumping the radiant back and forth right away each half cycle, instead of dumping it into a capacitor over many cycles, you know, and removing all these cycles into one cycle, into one long pulse. And if you keep the reactive power by dumping the flyback each half cycle, you keep the reactive power by doing it that way. If you do it by dumping the flyback over 1,000 flyback pulses into a capacitor, you just eliminated the reactive power by doing that. The reactive power being the reactive power.
Yeah. Well, what you're
Capacitive
ultimately,
reactance. The
yeah,
reactance of the
yeah,
circuit is what you're destroying it by capturing more than one pulse, flyback pulse, into a capacitor. If you capture two flyback pulses into a capacitor, you just destroyed the reactive power. If you
yeah,
don't capture more than one pulse, you only capture one pulse, and you keep capturing it back and forth instead of capturing more than one pulse into a capacitor, you capture only one pulse into a capacitor, and you use that pulse right away out of that capacitor. And you only capture one pulse into that capacitor and use it right away. That's keeping the reactive power going. If you
right.
capture one pulse at a time into a capacitor and dump it into a bigger capacitor and store multiple pulses into a bigger capacitor, you're changing the reactive power into a slower frequency. You're
Yeah.
losing the frequency of the
But
original reactive power
Right.
don't
being the
forget
radiant
too.
spike.
Yeah, I could see that happening,
And that
but
radiant spike happens on the half cycle,
yeah.
on
Now,
50% of the cycle.
now you also have to take in consideration too the size of the inductor or the coil that you're using to drive the motor. Now, I'm using most of my coils are at least 1 pound. The one in the Renegade's almost 2.5 pounds. So that coil alone is going to have internal capacitance. All right. And there will be a certain amount of resistance too because of the length of the wire. So that's going to keep the coil, I guess you could say, inflated. Instead of having the field collapse all the way down to the blotch bulb, I'm keeping it pumped up. So I'm always kind of like staying ahead. So what's happening, it takes a less power now from my input to keep that coil saturated. You see what I'm saying?
Because it has more mass.
Correct. Yes. Because of the induction size or it goes back to the Newman theory.
So the more mass the coil has, the longer it takes for the field to collapse.
Right. Exactly.
Kind of like a
And-
flywheel effect, huh?
Kind of, yeah. Like it's like if you go back to Newman too, right? He was using dead 9-volt batteries. He would put 84 of them in series, and he was pumping 460 volts DC at less than 50 milliamps, and he's driving a 7,000-pound motor.
But wait a
Now-
minute, 50 milliamps with 400 volts is a lot of watts. I think he was around, less than 5 milliamps. If I
It
have
could
to
have been.
correct you
They
there.
were all I know is he was using dead.
If you
9-volt
take
batteries.
400 volts and multiply that by 5 milliamps, you're looking at 50 watts or something.
Okay, but dump that 50 watts into a 7,000-pound coil.
You're not going to get 50 watts out of a bunch of dead 9-volt batteries.
But you're injecting a high voltage potential into a large inductor. It's the conversion from potential into a mass. And that's where, see, a lot of people think his over unity was coming back from the back EMF spike. That's incorrect. His over unity was coming
That's
from,
what I think. That's what I
no,
think.
it isn't. No, it isn't. It's not. It's the amount of power he's putting into the system versus the mechanical power that he has created. That's where the over unity is. He's able to move a 7,000-pound mass with a lot of voltage.
Right.
Yeah, I
Just-
mean,
right.
so even that thing that I made, which was
That's true.
I didn't know what I was doing, and I came up with what was. It may not have been over unity, but I hadn't used the mechanical output. And I on the last video I mentioned I was making a windmill motor, generator to put on the end of it to capture that, but I ended up not following through with that. So it isn't, it must not be that difficult. And I went through the thing of using the larger capacitors thinking that was better. And finally, when I got
Refresh
it,
my memory. What's an MOT? I don't remember.
Oh, what?
What's an MOT?
MOT.
Um,
T-Von, can you elaborate on what MOT is? Sorry, it's been a long
memory's
day.
rusty.
But what I was going to just kind of add to this, guys, is the fact that Newman was
Modulating output transformer? Okay. Well, the thing with the Newman coil is it's a thin coil, it's got a high resistance, and it's going to resist current, but you can still get the voltage through it once you get high enough.
But this is where his over unity is. You put that high voltage into a very large coil. What you're now doing is creating electromotive force. Okay, the electromotive force is the ability to do work. Well, the work he's doing is moving a 7,000-pound rotor. Okay, if you try to take a 12-volt battery and pump 50 amps into his motor, it wouldn't be able to push it. It does not have the physical power to do that. But if you put a high potential like 400 plus volts into a very large coil like that, that I'm trying to get across to everybody is the power is generated in the coil. The current, the electromotive force, everything that's driving that motor is created in the coil. And that's why that large
It's a pressure field. It's a pressure field. You don't need amps. You just need a volts for the pressure.
That's right. And that a lot of people
you just need a tiny 1 joule to get those volts through. I mean, sorry,
right.
you need the volts. You need enough volts to get 1 joule through that coil, and then that 1 joule will make that voltage on both ends of the coil, basically. But you don't need more than 1 joule to get that voltage to read across the coil, and then you're done. You got your voltage.
Everybody thinks you have to pump, 12 volts at 50 amps in order to make something turn. No, you don't.
You just need to get that 1 joule through there with that high voltage, and your voltage passes through it, and you're done.
Because the large mass is going to create an enormous electromagnetic field. That's what you're after. That's where the electromotive force is. That's where the over unity is in that electromotive force. And Newman understood that putting high potential into a very large coil or conductor, you're going to be able to achieve a huge magnetic field that could do physical work. That's why he had a mud pump hooked up to his motor, because he wanted to demonstrate not only that I'm moving a 7,000-pound motor, I can also drive a mud pump and pump hundreds of liters a minute through this pump. So that's where the over unity was. Everybody's going, okay, where's the potential? Yeah, he was creating a lot of back EMF, which he was dumping into very large capacitors. Yes, but the true over unity of a system
Was in the flywheel. Newman, you had the flywheel system.
That's right. That's right. It's all part of it. It's part of the equation, right?
But you can do it without a flywheel too. You don't need a flywheel.
No, but like my Renegade's kind of based on his technology as well as Robert Adams.
The flywheel
It might
definitely
have-
helps. It definitely makes things easier.
Yeah. Like my motor for its size has quite a bit of torque for, for what it is, but not, see, even Paul Babcock, he did a lecture a couple of years back, actually just before COVID, I think. And he's going, everybody, get away from the 12-volt battery. He says, start using 24, 48, 60, 100 volts. Get away from the 12-volt battery.
What was his
Don't-
reasoning for that?
Joseph Newman.
Oh,
Joseph Newman was the one guy that caught his attention in his early years, that got him thinking.
what was
about
his reasoning for using higher voltage instead of lower voltage?
Because you don't need amperage to create an electromagnetic field.
Right.
You need potential, not current. So my motor, I have a 49-volt battery bank, right? For motorcycle batteries in series. Okay, so I get about 48, 49 volts, fully charged 50 volts. So let's say 50 volts. Now I'm dumping that into a two point, almost a 2.5 pound coil. I'm creating a huge magnetic field. And when I put a current meter up to the battery to see how much pull is coming off the battery, it's telling me 20 milliamps.
Well, hold
So-
on. These meters can't read radiant energy like you think they can. They
No,
can
no,
read
no.
some
I'm
of it.
pulling. No. I'm not reading.
You
vacuum
got to have those
stuff.
analog meters
No,
to even get
no,
close to
no.
that.
I'm talking about pulling battery power off the battery to drive the motor. So that's standard.
Oh, okay.
battery
Yeah,
power.
that you can read. Right. Yeah. Okay.
That's what I'm reading. So the amount of battery power it takes to make my motor run, 50 volts at 20 milliamps. Do the math.
Right. That's it's like
What? Less than 2 watts.
it's 1 watt.
1 watt. Yeah, 1.5 watts. And I'm
50
getting
volts.
700. Yeah. Got a calculator there? Yeah. I think it's 1.8 watts. I think it is somewhere in that.
It's 1
range.
watt, dude. I was right.
Yeah, 1 watt. So now I'm getting 765 volts.
I got the math
at
in my head. Man.
300. Okay, I'm getting 765 volts at 300 milliamps of current on the other side. So
Say that
where's
again.
this at? 765 volts at 300 milliamps.
Oh, that's definitely that. Is that your flywheel getting you that extra?
That's the output power. That's my flyback output power.
Oh, no. That's just the
And I'm
flyback.
That's just the flyback I'm getting on the other side.
And you're using the transducer to get this increase
That's right. I got 30
in parallel with your coil.
Yes. Directly in
Yeah.
parallel with the coil.
So the barium
Oh.
is having an effect.
Huge effect.
You know what's
It was
another way to do a flywheel solid state? You're never gonna guess it, but it's an electronic component. Very popular one. It's a capacitor.
Yeah.
It's the same thing as a flywheel, is the capacitor. It's just a solid state flywheel. So the capacitor will
really all the wheel is to provide two things. One, a timing mechanism to trigger the circuit, which that's basically the
No, but the
primary.
wheel stores your energy, your buildup
That's right,
energy.
mechanical energy. So if I were to put mine up to a meter to find out the actual amount of mechanical energy my motor's putting out versus how much joules of power that I'm using to actually run the device, my motor is way over, hands down.
And without the transducer, you were getting less.
About 30% less power.
And what
Now,
did you say
there's,
gave you the idea to use the transducer again? Is this you just thought
It
about
was
it?
just it just came up an idea. I was doing some research on piezoelectrics,
That's smart.
and I just picked up a cheap old transducer off of Amazon. The little wafer ones, the ones you find in postcards that sync. I just hooked it up and I hooked it up in parallel, and boom, my whole circuit just came to life.
Did you ever try measuring the transducer for capacitance or inductance?
No. It's a reactance. It helps from what I see. And
But
what
it is
I've
two plates
observed.
of metal, right? So
Yeah, you got copper as your base or your negative. The barium titanate wafers basically on the top. So when you hit that with electric voltage, see, like most people, the way they use it is you press it, physically press pressure on it, it creates a voltage. That's how most people use it. Or it's used as a pickup for a guitar or a musical instrument. They're very popular for that aspect. But nobody ever thought of, well, why don't you hook it up to an inductor and inject power into it? Nobody's ever done that. And the way I've done it anyways, I've looked all over YouTube and nobody has done what I've done. And I've had a few people say they've tried it and they go, holy cow, what the hell happened? So
which side is the copper on? Is it on which
copper
metal?
is the base. The copper is the base, and then
No, you said you had it in parallel with your coil. You had it in parallel with your coil. But which metal is on the flyback side? Which metal is on the anode side of the flyback diode?
It all meets up at one point at the 2 points.
Yeah, but you're before the flyback diode, right?
No, this is
you're in parallel with the coil,
right? So
but you're in parallel with the coil, but before the flyback diode, not after, with the transducer. And no, it's the barium's touching the flyback side, or is it the copper touching the flyback side? Where the high voltage diode is. You're on the anode side of that diode.
Well, because it's I see what you're saying. Okay, so what's happened, because it's in parallel, you got your positive side and your negative side. What's happening, it's almost like a power reduction circuit where you put a resistor in between your positive and negative.
Where's the barium touching? Where's the barium touching on the coil, on the flyback side or on the other side?
It's part of the same circuit.
Well, I mean the positive flyback side. Is the barium touching the positive flyback or the negative flyback?
It's the positive, and then the negative
is on the anode side of that diode, right?
Yeah. I put a flyback diode just before that, just before the coil.
So it's on the anode side. The anode side is the triangle, and yeah, right.
All I say is just hook it up and try it for yourself, and you'll see what I'm talking about. It is very obvious what's going on.
Yeah, I don't have a lab right now. I'm working on the.
Anybody who's listening to the show, try it. Yeah.
I intend to when I get my lab going again.
Yeah. See, T-Fun's right on top of this.
Hey guys, I'm gonna check out.
You're gonna check out for the night? Yeah. Thanks a lot for joining us.
Yeah, and by the way, the picture is over Unity. It's lizards. They figured it out.
Good meeting you, Reed.
All right. Yeah. Nice meeting you. You guys have a good night.
Yeah.
Take care, man.
Take care.
All
Thanks
right.
a lot.
All right. Good luck.
All right. Cool. So yeah, we've been on an hour and 30 minutes. I think. How long have you got, Mike? Go say another 30
I don't
minutes.
even know what time it is that where you're at. I mean, it's like
It's 10
10
after
p.m. here.
10.
Oh, it's 10 p.m.
10
here
after
too. Yeah.
10. Yeah. So we're about the same. Maybe another 30 minutes and we'll call it a night. But
Sounds good.
yeah, no, let's talk about the circuit because I want people to try it. I don't see anybody using transducers out there. All my circuit is a modified Bedini circuit with a transducer. That's all
Did
it
you
is.
try more than one transducer in
I
parallel?
tried a couple. I've tried 3 different types. The one I'm using right now, the wafer one that you can buy on Amazon, is the one I'm using right now, and it works great. It's very easy to hook up.
I'm saying you
Solder
could put
2 motors on it.
multiple in parallel and get more.
I've
output.
the one motor I have right now, I got 2 of them hooked up together. They work really well.
2 transducers in parallel, right?
Yeah, yep, in parallel with the coil.
And with one, you had less output, huh?
Yeah, I find there's a gain. As soon as you add a second transducer, it bumps it up even higher. It's like
And then you were just happy with that and you just left it as is.
It's weird. I tried it with one and I got a 30% gain. And then I added a second one to it, and it's like it hit a different octave. And then I got
Hmm.
even a higher spike. So it was really cool. It was, yeah, when I first did it for the first time, I'm looking at my meters and I'm seeing this gain. And I go, okay, well, I'm not putting any more power into it. Actually, if anything, I'm putting less power in now because the current from my power source actually started decreasing.
And what's stopping you
So
from pulsing a transducer all by itself without a coil?
you could, well, that's what they use for ultrasonic cleaners. So you pump that
Oh, right.
that's what they use in the ultrasonic cleaners, the transducer, or those fogging machines, that make the fog, the misting fog. Yep. So I've seen people, yeah, you could do many things with it. So
Probably even put
yeah.
a capacitor in parallel.
Sure, you could, yeah. Well, the coil itself, I'm using a 2-pound coil. That's got capacitance all on its own right there. You could also add more. Like I put, what was it, a 1200 volt, uh, 8 microfarad, like the big friggin' capacitor, huge, like this. It's like a
Yeah,
brick.
I
I
got a
put
few of
that up.
those.
Yeah, I got 4 of them. They're
1200
oil,
volts.
1200 volts DC at 8 microfarad. They're
I think
huge.
the highest one I got is a 900 volt one.
Yeah.
Why? That's
These
a. I don't know how you found that one. That must have been
Oh,
hard to find.
no, actually, there was a guy that was listening to my show. He's in Connecticut, and he sent me 4 large ones. Yep, FedEx or UPS right to my house.
He made them probably. Yeah.
No, he works for a company. They make submersibles,
Hmm.
submarines. So he works with a lot of big
Special order.
industrial. Yeah, it's all the stuff he does is custom made submarines, submersibles, stuff like that. So he's an engineer too, right?
So I
But
was trying to get
definitely,
away from transistors,
yeah,
trying to use
transistors.
capacitors.
Use capacitors and use disruptive discharge. Use the spark gap switch. You're going to see some interesting stuff. You got to think too. Tesla didn't have transistors. He was using rotary
That's
spark
a.
gaps.
I've never worked with spark gaps, but
I'm telling. I'm really telling you, try those spark gap switches and just bend the armature on it closer to the other pole, and they'll actually trigger a lot faster. You can make them pretty fast.
can you
Like
bring
I
that
can,
this up this schematic here? I think I could put a spark gap on the positive and the negative of this battery, like you said, and that might create the switching if the capacitors don't do it. I don't know if the capacitors are going to do the kind of switching I'm hoping it will do. But you mentioning Spark Gap, I think I can add this here to achieve that easily.
Actually, you can share that link if you want.
I put it in the comments.
Yeah, I got it there. Yeah.
Can you bring the video up so I can show you the circuit?
I'm not sure how to
And I
do
want
that.
to see what you think about putting a spark gap. Where would you put it? Or two of them, actually. I'm thinking putting two of them. On
Actually,
the
can you
capacitors.
put it in the private chat, that link?
All right.
It might be easier for me to grab it.
Who's making it?
I'm just gonna share my screen here.
I don't know why I don't use spark gaps, but I probably should be. Yeah. I think it's better than a transistor. You can't blow out a spark gap.
Hmm. Too many windows going. Share. Can you see the video up on the screen? Okay.
It's loading.
So this is the circuit you're talking about?
It's still loading.
Oh, it's up on my screen.
Oh, there you go. Okay.
So is that
What
the
do you
circuit
think?
there?
Yeah.
Okay, let's just pause that. All right. Diode. Okay, so what you want to do where you hook up that spark gap switch is right on the positive between the junction where where the diode's coming out the side. See where my can you
That's
see
the
my
flyback diode.
That's the flyback diode. Okay, so what you want to do is eliminate this here. Okay, take that out. You're going to put the spark
That's
gap
good spark.
switch right here. Spark gap
But
switch right
once
there.
you put it on the capacitor, right? Yeah, that's what I was thinking. Yeah. That would cause it to spark, right by the capacitor. No?
Well, you could put it before. Okay, so the spark gap switch.
You're looking at the flyback. The green is the flyback. The red is the DC forward.
Right. So mine is right basically here. This is where my spark gap switch is right here.
Right.
Okay.
Do you
now
think
the
this would
flyback-
pulse without a spark gap? Would this thing pulse with the capacitors alone? And I think it would just rise and fall, the voltage, but it wouldn't quite pulse. But if we added a spark gap and it when the voltage rised, it would
Sure.
pulse through this.
If you're able to make that thing go, cycle, 200 hertz, yeah, things are going to happen for sure. You just got to trigger that relay switch fast.
The idea is for the two capacitors to charge up and create a short for the positive and negative of the battery to charge that coil.
Yeah, because what I've done is I've taken my flyback before and just dump it into a capacitor, and it has no problem filling it up at all. Because the inductor is where the collapsing field is creating the current. The current's being created in that coil inductor. So if it's creating current or electromotive force, you've got amperage now, and it's going to force its way through, and it's going to fill up it's going to fill up that capacitor very fast. Like I got my that large oil filled one I was telling you about, the 8 microfarad 1200 volt. That thing just filled up like fast. I was so impressed.
So you don't see this thing pulsing
No, it could. You have to put it right here where my cursor is, right at the beginning of the circuit. This you would have to relocate probably, I would say, after the capacitor, because if this thing's firing, it's creating a huge reaction here. It's going to be forced out in that direction. So if that is creating a back EMF within the capacitor, you're going to want this flyback diode probably somewhere in here, in this area. You have to experiment with that. Like I could speculate. I haven't actually built it, so I tried different combinations. I tried different locations for my diodes, whatever I'm using in the
Mike,
circuit.
that's the negative side of the flyback. It's not going to go through that capacitor because the capacitor will be empty. It won't be charged.
Right.
During the flyback, it's not charged. When the capacitor is fully charged,
So this one here, I would just eliminate altogether.
but if you do that, then there's no way for it to charge the inductor.
Well,
if you
can
have to
charge
have
it.
that
You
circuit
can-
there. I mean,
Well, no,
you can.
can
Well,
charge
okay.
it
So
over
let's
here.
say we did remove that capacitor, and then it's a straight connection. Then when the flyback occurs,
Right.
it's going to go up that diode and around to the
Well,
to
the
the other
diode's
end.
still-
It's going to short out. It's going to short out the flyback. Without that capacitor there,
Okay. All right. So
You see
I'll
it?
tell you
You
number
see it?
one. I'll tell
did
you.
you see that?
Okay. Yeah. I
Confirm
see
that you saw what I just mentioned.
Yeah.
You see what I'm talking
No,
about? The
no.
negative is going to go up that diode and around to the positive side of the flyback and short itself out. In other words, cancel
Right.
out the flyback. So you
That's
got to
right.
have that capacitor there because it
Yeah.
has to open and close that circuit in that pulse fashion.
Okay. What I see, the other thing I see, and I just realized it now. What's the problem with this circuit?
But there won't be no pulse without a spark gap. I think this is just going to be a rise and fall because it's capacitors,
Hold on a sec. Just hear me out. This circuit here, the way I see it right now, is kind of counterintuitive because you need to change the symmetry of the power coming into the circuit. So what's going to happen is that thing is going to short out. This whole circuit will short itself out.
Well, of course,
Period.
it's supposed to short out the coil and charge it. And then the capacitors, once they are full, they're going to short out that coil. The coil is going to charge up. It's not going to be able to take a charge anymore. It's going to resist back onto the capacitors and stop. And the capacitors will be drained at that time because they drained into the coil. And when the coil takes that charge, it creates a resistance. And I'm sorry,
No,
it takes the charge.
The
When the coil
symmetry
takes
has
the
to be
charge,
changed. See, Tom Bearden talks about this extensively. He says,
well, there's only one inductor here, so there's no way to change the symmetry.
you have to, because what
There's
happens
only one
is,
inductor.
even with a pulse motor, okay, if you take a pulse motor and you loop the flyback right back into the initial battery, it kills the motor.
I see what you're
you
saying.
have-
Okay, I get you there. But
right,
let's
you have-
forget it. We could change this to a water battery or something that won't be killed by the pulse. I mean, just the battery's just there for conceptualizing.
Yeah,
Yeah. I'm sure there's a storage device out there that won't get destroyed. But I know, yeah, you're right. The DC batteries cannot do this.
Oh, yeah.
I understand.
it will.
What if you
short
had two?
itself
What if you
out.
had two batteries in parallel? Then that means
Yeah,
the
well-
one battery that's giving the load, while the one battery's loading, the other one can take the charge, so they can work
That's
together.
Exactly right. There you go. That sounds better because the symmetry does not have to be changed now. Yeah, for this circuit to work, you need two batteries. The way I
Right, so
see
you
it.
put two batteries in parallel, and that would solve that issue. But it's still, again, I don't see this thing
separate.
pulsing.
No. Put the two batteries in a completely separate from the circuit. The only place where the connection is going to be made is the flyback. That's it. With the diode.
Right, well, that would be the Bedini thing.
Yes, exactly.
So then, but I still want to switch with a capacitor, not a transistor.
You can try it. You have to experiment. You just have to experiment with it.
I
All
think
the
the
stuff I did.
capacitor like this with the spark gap would create the switch, but the capacitor alone would just create a tank circuit with the inductor, and you would have a rise and fall in voltage, like an AC sine wave, not a DC pulse, which is
It'd be
different,
interesting to hook. It would be very interesting to hook that up to a scope and actually see what the waveform is.
right?
Yeah,
Yeah, I mean, this is not set in stone. This is just to get a concept with switching
sure.
with
There's many.
capacitors.
Yeah, experiment, man. You got to experiment. You have to try these. You know, it's
But
good
do
to
you
come
see
up.
this thing switching as it is? Do you think these capacitors will switch, or will it just create a rise and fall like a regular tank circuit? Like an oscillation instead of a pulse.
Yeah, I see it operating kind of like your typical tank circuit.
So it'd just
Yeah,
be oscillating more of like an AC signal.
yeah, yeah, yeah. Because you got the
Uh,
inductor, you got two capacitors on each side, voltage input. Yeah, it's your typical tank circuit.
and then if we add the spark gap there, that would convert it from a rise and fall to a pulse.
It will create a DC pulse, which is a makeshift or a cheap man's AC current.
Oh, God. It's just, I think the only way out of using transistors is a spark gap.
It is. And why do you think I got away from a transistor a long time ago? I got rid of it a long time ago. I knew it was night and day between the two. And also the charging characteristics. I was finding I was getting a way better
Hmm.
charging characteristic using the relay switch. I was sitting there one day, I'm holding a transistor or a relay, solid state relay, and my mechanical relay. I'm going, damn it, which one is better? And I went with mechanical, and I've never gone back.
Well, a mechanical relay is kind of a spark gap, but I thought you were talking about like
That's
a
right.
like a
Well, I'm
like a
getting
like
that green blue spark from my switch, and that's the radiant spark. As soon as I see that bluish green spark, that's the radiant spark that Bendini talks about.
from your
That's what
automotive
it is.
relay.
Yep. And it doesn't burn out my relay, and my relay does not heat up
Hmm.
at all.
Because you're
I can put
keeping
my
it low on the voltage or whatever.
well, the radiant spike is a cold spike. It's not heat. There's no hysteresis of power there. So I can put my finger on that relay switch with my bare finger right after it runs for 20 minutes, and it's cold. There's no heat at all. Zero heat. If anything, it got cooler. That's the
What was your
crazy.
input, your source voltage again? 12 volts?
Well, with the Renegade, I'm using 50 volts at 20 milliamps input.
So the higher voltage is helping you
Oh
diminish
yeah,
any heat because you're getting through the coil a lot easier.
yep. It's the driving force. That's the driving force, and that's what you need with a big inductor.
So
You got
basically,
the
the heat is
driving.
coming from a 12 volt system. When you see heat, it's because it's not enough voltage to get through that coil. It's just
That's
yeah.
right. It's lacking. It's lacking the potential push. The voltage
That's
creates the
starting to make sense.
push.
Man.
It makes total sense to me, and I've never gone back.
So you're
I start
raising your
realizing.
voltage and lowering your amperage at the same
Yep.
time.
And Paul Babcock's doing the same thing in his system. Jim Murray, same thing. Get away from the 12 volts, people. Get away from it. Start going with 24, 48. Go up high as you want. I got right now on my
But the
little
more you
Renegade.
raise your voltage, then you got to start putting limiters in there and some way to drop
Actually,
the current.
no, actually, I'm using a little high voltage circuit that they use for neon lamps. And if I put in 12 volts DC at 50 milliamps, I can get 238 volts. And I'm slamming that into my little Renegade right now. I'm testing it. And it's freaking incredible what's going on in there. Absolutely incredible. I got a 1 pound coil, 24 gauge, with welding rods as my core. They're isolated. I wrapped them all each one of those iron rods. I wrap up with electrical tape so they're all isolated from each other. Put it in epoxy, shove it in the coil, let it dry, and boom, you got your coil. So, and I'm getting phenomenal results from it. I was charging up batteries last night. I did the Tom Bearden phase shifting symmetry, and I fed that power in one side and fed it right back around on the other side on the flyback, and the motor ran strong. It didn't short out. Nothing. I took a dead 12-volt battery and charged up another battery, and then I flipped the batteries around and did the same thing over again. Now I got two charged up 12-volt batteries with no external source coming in to add power to the system at all. So now what I have to come up with is a very good battery swapping circuit.
What do you think of
So,
my circuit? Well, my circuit swaps it every half cycle.
yeah, well, I'm going to do mine a physical swap. So the charge one is going to be, running
No,
the
it's not
system.
a my circuit's not physically swapping. It's swapping with the relay
Right.
configuration.
Yeah. Yeah. Yeah.
But it's
So
doing it every half cycle.
mm,
That's why it's able to
mine's
do
going to
it.
be, yeah, mine's going to do it a little bit different. I'm going to put it like every 2-minute cycles. So it'll be
Right,
every
but what I
two
was saying
minutes.
earlier, when you do that, you lose the reactive power. You're not keeping the reactive state of the system, which is
Well, the
half
reactive power is in the
which is in the
coil.
frequency of the system.
Yeah, well, the reactive power is in the coil itself. Now, the larger the coil is, more of the reactive power is held within it because of the internal capacitance of a large inductor. The bigger the inductor, the more internal reactive power can be stored. So if you've got a small little coil that's only 300 turns, it's not going to
I
hold
thought the
that
reactive
much.
power was the frequency.
Well, it's the frequency going through the large inductor because any large inductor has an internal capacitance. So when you're sending a high voltage in there, you're creating a
No,
much bigger.
the inductor has inductive reactance,
Mhm.
and the capacitor has capacitive reactance. But
Yeah, but
they're
the coil does have capacitance. A lot of people don't realize that.
well, yeah. That's
Coil does
called they call that. Uh, yeah, right. It's called Henry's.
hmm
Millihenries.
You're storing the potential in the inductor.
They call that Henry's,
So
whatever.
yeah,
Yeah.
the faster you cycle it, that magnetic field stays inflated. It doesn't fully collapse. You're getting the pulsing there, but the actual field itself is still present. It's still there. And that's why all the current demand off the battery that runs the system goes down. That's why I can run it at 20 milliamps and the motor keeps speeding up. So yeah, interesting little circuit. I would definitely experiment with it, try different configurations.
Well, the thing
I
about
find
but having two capacitors, it won't work with one because the flyback, either the negative side of the flyback will short out to the positive, or the positive side of the flyback will short out to the negative, and that's why you have those two capacitors. To not short out the flyback, you have to switch the two ends of the one inductor.
yeah, you would definitely have to. I've never done a circuit like that, so it kind of be
You could
hard for me
switch
to.
those capacitors for spark gaps or whatever, or even put two spark gaps in series with the capacitors to create the switching. With the timing of the switch would happen by the microfarad rating of the capacitor would determine the switching timing of the spark gap.
Well, T-Bone was saying the Aaron EV Gray motor switch setup would work. Yeah, and my motor kind of runs very similar to the EV Gray switch.
I don't remember
It
what
is.
I'm familiar with the name, but not how that system works
Yeah,
yet.
I would research the EV Gray motor. That's a really interesting motor. Definitely a very interesting motor. He developed it in the late 70s, early 80s. He had a very good working model. He pretty much had to go in hiding. He was threatened and I think they tried to take him out a couple of times. Last time I heard, he was living in a trailer park somewhere in Florida. I don't even know if he's alive still. I think he's passed on by now.
That's just fear porn and propaganda.
But yeah,
There's plenty of that going around, you know.
yeah, it happens.
It's the news. Don't even watch the news. It's full of, you know, fear propaganda.
Yeah, like Moray and Floyd Sweet. He almost
I
got
don't believe
taken.
those stories that they say about these inventors. I don't fall for it. I think
You
it's
don't fall
all
for it?
I think it's just fear propaganda because if you look at real life, there's plenty of avenues of fake fear that is created all over the place throughout man's history, and it's just been shown over and over
Well,
again.
the other one
The
too.
lies, you know.
Well, look at Stanley Meyer, right? He was poisoned to death. So he went.
How do you know that wasn't just a lie? Like the
Well, put
pilots
it to you this way.
of the space shuttle are still alive today.
Okay,
Right?
put it to you this way. I found
Just
this information. I found
too
this
many lies out
information
there to
out.
believe anything anymore.
Well, put it to you this way. I found out through the grapevine a couple of people that are in the know what happened to that family. After Stanley Meyer died, his brother still wanted to carry on the technology. He was also threatened too. And last I heard, he does live in Canada. And I won't say what province he lives in, but I know where he lives. So he's been pretty much in hiding. Like yeah, like seriously, he had to leave the U.S. because of it. So there's a couple of guys that actually have fled to Canada because of that. So the other one is Jim Murray doing all the Tesla stuff with his. He's been working with Babcock, but he had a couple of incidents happen at his place. I believe he was in Texas or something. He lived, but now he's in Canada, and I know exactly where he lives. A lot of people don't know where he lives, but I do.
I've heard the
So yeah,
name Jim Murray. I don't.
yeah,
I can't place the face though. I mean,
yeah.
I-
Look up Jim Murray, and him and Babcock are good friends. They've been working on a very interesting switching system, which got patented. So yeah, Jim Murray. He doesn't live in the U.S. anymore. He's in Canada.
yeah.
So yeah, I don't know his story or how he got threatened or what happened, but yeah, he's in Canada now.
I heard from Bedini. He said, I mean, I heard Bedini say himself. I don't know if this video is still on YouTube. I saw a video of Bedini saying that he heard secondhand from one of Floyd Sweet's friends that Floyd Sweet was coming to his house and he dropped his keys and he heard something hit the wall. Floyd's
Yeah,
blind, you know, and he
yeah.
said that
Well,
later they found out there was a bullet in the wall. You know?
yeah, missed his head. He was an older guy, so you know you get a little clumsy when you get older, and he basically tripped over his own feet going up the stairs. When he fell forward, that's when the bullet just grazed the back of his head. So that really freaked him out. He was shot at it more than once, from what I've been heard, what I've been told. He's been shot at more than once. But they say, oh, he died from a gunman. I don't believe that. He died of old age. I think that was a bit of a myth. Um, I think he was already in his late 70s, early 80s when they were doing the videos with Beard, and I think the one video they did was
Hey, you know, I used to be a landlord. I got plenty of enemies, and I'm not nobody special here. You know, we all have enemies. You know, like doesn't matter who you are. There's always an enemy out there for you. You know, so I don't believe that these stories are totally accurate. You know, maybe yeah, there's people that just hate and envious people, and you
Well,
know,
there's other special interest groups out there that don't want this stuff to come out, but
I honestly,
unfortunately,
honestly don't think these special interest groups are could care at all because they're so busy making so much money they don't even care.
well, that too. But the other thing too is now the internet's kind of like the genie. When you open up the bottle for the genie's out now. The internet, this information that we're giving out tonight, this stuff is going worldwide. My YouTube channel is seeing 51,000 impressions every month. So that's 51,000 people getting the information off my website on YouTube. Plus, I'm on Odyssey. I'm on Twitter. I'm on.
Yeah, but what we're talking about is just general
Instagram.
electric theory, you know?
Well, we're not doing like spooky action at a distance. This is just taking electrical engineering to the next step. I don't think we're breaking laws of physics at all. I think we're doing stuff, we're tapping into stuff that, you know, regular electrical engineering.
We're not doing anything different than what Elon Musk is doing, you know, with his
You're right.
Powerwalls.
You know, like what we're doing is we're taking a potential which regular engineers would just short out, right?
Right.
Especially with DC motors, they would just
Well,
short
we're
out.
all, well, you know, it doesn't have to be flyback energy. It could be solar energy. It could be wind. It
Sure.
could be,
There's a
you
lot
know.
of technologies out there. Like right now, I've been studying the Stirling engine, and apparently that motor is starting to make a bit of a renaissance because you know, you could use any kind of fuel source. You could use gas, you can use propane, you can use wood. It doesn't matter. The Stirling engine will work on any fuel source available.
You know what's crazy
Geothermal,
about that engine? Is you can
200.
create huge diaphragms and
Yep.
increase your output like you can't believe. Because the more
Yep.
diaphragm you have, the more temperature differential space you cover.
That's right.
And there goes
That's,
your efficiency goes way up.
Oh yeah, way better
Like,
than the internal combustion engine, hands down. It's easier
but
to
then
make.
again, those diaphragms
hard.
require, you know, like special type of wood and, you know, or material.
Doesn't matter. But the
It's
thing
not
is,
easy to make.
but the thing is now our material science is starting to get so much better versus, you know, what Robert Stirling had 200 years ago.
Can you imagine a
Our-
carbon fiber Stirling engine made out of
Sure.
carbon fiber
Oh yeah.
with a huge diaphragm
I-
made out of carbon fiber?
Guys are 3D printing them now. I just seen a lecture. A guy he was out in Vancouver doing a lecture, and he's got a class where he's doing making these engines with 3D printers.
The 3D printers can't print that big though. They have a certain, you know.
No, well, I got one that can print 8 inches by 8 inches. So.
Yeah, I'm talking about like, you know, a couple feet or diaphragm.
Oh yeah. Well, yeah. Obviously, you're going to get into different materials, but I'm saying for the average person at home could actually build
Imagine a Stirling engine standing 10 feet tall with a 6-foot diaphragm.
Yeah.
How much, you know, how much, and you got more spatial material on the surface of the Earth and the other half below the Earth.
Yeah.
You're already going to be having movement because of the temperature of below the Earth and the temperature above the Earth. And when the sun's hitting the metal on the top, it's going to even speed up.
Another one. Oh, I forgot to mention this one. This is another good one that you can look up. Is the nitinol engine, the memory metal engine.
I know that one.
Yeah, they apparently were doing big research on that one back in the 70s.
Isn't that nickel and something else?
It's nickel and titanium. Nickel and titanium. Yeah. So you can get a hold of that stuff, and then it will. Apparently, it's got.
I think the Stirling engine's better. I still do. I don't think nitinol is all that. It's
a lot of parts to make it.
It's doing the same thing as the Stirling engine does with temperature differential, but
yeah, it's doing.
When it comes to building something, you know, it's easier to build a Stirling engine than a nitinol generator.
Yeah, exactly. Yeah, Stirling engine's a lot less parts than, you know, like internal combustion engine, lasts longer, doesn't break.
And I still think the Stirling engine will put out more than the nitinol. I really do, because I like that whole thing about the air chamber inside the Stirling engine. It's the air inside there. It's a different temperature.
I think really it just boils down to the engineering, right?
It's the ability to get the hot air to move out the sides of the chamber smoothly, to have the hot air or whatever, the cold air. I can't remember, but The center of the chamber is where the hot air is, and the sides is where the cold air moves. Something like that. But it's highly effective, efficient, because you don't need to if it's big enough, you don't need to give it a flame or heat or anything, because it's got enough
Right.
surface area. Your what is it called? Heat sink?
Parabolic mirror.
It's like a heat sink.
and yep, yeah. I've seen them use parabolic mirrors and using the sunlight to heat up the hot side, and man, they fire up real fast.
Yeah. I mean,
The
that's the
parabolic
best way
mirrors,
to
man,
power
they can
anything
create
is a
huge
Stirling
amount
engine.
of temperature, 500-600 volts or Celsius, even higher.
If
They're not
the
very big.
combustion
They're
engine of a
about
car was
14
replaced with a
inches in
Stirling engine,
diameter.
good.
Yeah,
Sorry about that. You got some
that's okay.
delay there.
Yeah,
I was
I'm
just saying,
outside
if you
having
switch the combustion engine, if you switch the combustion engine for a Stirling engine in a car,
Mm.
you know,
The only problem is you would have to go to a manual stick because you cannot, have an accelerator like you do in a regular car. Stirling engine, as soon as you turn it on, it's on. You know what I mean? So you would
right.
have to go. You would have to switch to a standard.
Right, because of the
stick and
flywheel on the clutch, right?
right, exactly. But there's many different ideas what you can do, right? Stirling
Well,
engines,
the
pretty
best way to
intriguing.
use it is to spin a three-phase generator. It's what I would do with it, and then go electric on the car if you want.
Sure. Like
Or
you
use
can
electric pistons, solenoid, electric solenoid,
use solenoids. Yeah.
instead of an electric motor per se, which is vulnerable to the elements. You could use electric solenoids on your combustion engine.
Yeah, you
on
can
each
do it.
piston, and
They're
power
gonna have
that
flyback
those
on those
solenoids,
too.
power
The
those
solenoids
solenoids
create a
with
big
the
flyback.
Stirling engine.
And the solenoids too, they can create a huge flyback too. I've done a couple experiments with
That too.
the solenoids. They give a pretty nasty flyback.
Can use the flyback from the solenoids the same way they
Yep.
use the regenerative braking systems. I don't know if it's
Yep.
doing that actually. Maybe that's what the regenerative braking does.
No, the regenerative braking is just you're not putting voltage into the system because the electric motor is really a motor and a generator. So if you're
But
putting
when you're
mechanical
braking,
power,
when
when
you
you're
brake on an
when you're
electric car,
braking, it's
it's
turning
charging.
into a generator. Yeah.
So it's just using a stator to stop the wheel with
Yeah,
lens
or
force.
you're just taking the electrical power away from the motor. Now the motor's creating power, right? Or manifesting power into the system. Generators don't actually generate electricity. It manifests electricity through an arch form that creates electrical potential because you need two components to make electricity. You cannot have one without the other. One, it is a dielectricity and magnetism. Without those two components, you don't have electricity. That's one thing I learned from Darwin.
Yeah, I'm starting to hear that a lot. You don't have electricity without, again, what did you say? The magnetism
Magnetism, and dielectricity. You need
and
those two
dielectricity,
components.
meaning the two directional fields of
The environment. It comes from the environment.
well, of course, you have to put the electricity through the wire, though, right?
No, it's manifested into it. No, it's
With your
just an arch.
voltage.
The voltage is created by the arch form of the magnetism created by the rotor and the magnets. That's drawing the power from the dielectricity into the system.
Oh, right. I get you now. The
So
motion.
you need those. Yeah, yeah. It's just an arch form. That's all it is.
You're supposed to pass the north and south over a coil, the arm of the coils, to get your alternating current.
The dielectric field goes and passes through the
So
magnet.
when they say dielectric, you're meaning the north and south. Okay, I got you.
It's coming from the environment. There's no other
Well-
place for it to actually come from.
Doesn't dielectric mean two? It means two, right?
Or-
Two parts.
yeah, it's two parts.
That would be the north and the south.
Well, you can kind of almost look at it like this, as kind of like a static field. Static potential.
I say the static field is the on and the off. AC is the north and the south. Static field could be a north on or a north off, or a north on and a south off.
Listen
whatever.
to a lot of. I suggest everybody listen to a lot of Eric Dollar's videos. He did lectures on.
Yeah, he's way ahead of me, man. I barely catch what he's saying.
Well, because he
10% of the
learned from
time.
all. He learned from all the old schoolers. He learned all this stuff from all the old school guys, right?
I do listen to him though, regardless. You know.
So he's probably one of the last of that breed. Yeah, so well, we're at over 2 hours here. I think we'll call it a night.
I hope you had a good turkey day.
Well, my turkey day was in October. In Canada, it's a month earlier than you guys.
Oh, really? I didn't know.
Yeah,
that.
we had ours second week of October is the Canadian Thanksgiving. 'Cause,
Oh,
we had
that's
a bit of
right.
snow flurries today. We had a little bit of snow flurries here. The north of us got a bit of a storm. So yeah, it's getting cool. Summer's over. We're heading into winter now.
So there is a Thanksgiving for Canadians, but it has nothing to do with the Indians and the corn.
No, it has to do with when our harvest is. So our harvest starts the beginning of October in the
Oh, it's a
U.S.
farming
because
thing.
yeah, it's all based on the farming thing. So like you guys live a lot more south of us. Your season changes later than us, right? Because you're a month behind.
So Thanksgiving has nothing to do with the Indians and corn.
No, it has to do with the farming. All the harvest.
Why do they teach
starts
us down here in North America that it has something to do with thanking the Indians for teaching us how to farm corn?
Could be. Who knows?
That's what I remember from school or whatever.
Yeah.
Great.
Yeah.
Weird, huh?
Yeah. So much. Yeah. So many different topics and a lot to cover. Yeah. It was a good show. We had a good conversation today. We'll be doing it again next week. Next Friday evening at 8:30 Eastern. And I hope everybody that joined us tonight can join us again. It's going to be open lines as usual. And hopefully Mike will be back again next week. What's his name? Philip in Montreal. He's getting ready to do his conference in Washington. And I asked him to join us tonight, but he said no, he had to get ready for the conference next week. So he said in about 2 weeks' time he'll be back. We'll be doing shows, I think, right up to the week before the weekend of Christmas, which will be the 23rd or 22nd, I think it is 22nd. It'll be the last Friday. So I think that Friday there, we're not going to do a show until probably the new year. So probably got about 1 or 2 more shows to do. And then we'll do a show in the new year. And hopefully we'll have some more guests on. I haven't heard from Bernie today. I sent him a link. I sent a few people links. I know Gerard's kind of funny with his schedule. So hopefully we'll get Gerard on, Gerald. I keep saying Gerard. I don't know why. Gerald. He's out.
He's
Winnipeg.
time traveling right now.
Yeah. Yeah, he's got
He's
some
in his
pretty
lab.
cool stuff.
Time
Yeah,
traveling.
he's all over. Yeah. Maybe he's disappeared and nobody knows where he is.
Hey, Mike, have you got time on Saturdays? Have you heard of Alt Propulsion?
Yeah,
Channel?
yeah, those guys. Yeah, I know all those guys. Yeah.
Hmm.
the
I'm on there
APAC
on
guys.
Saturdays. I listen in
Yeah,
on Saturdays on the Zoom.
yeah. I've been on APAC a couple of times. I just
Oh yeah,
don't really go on it because they're
yeah.
more
It's
into the
anti-gravity,
anti-gravity
so
stuff. So it's not really my
it's an
thing.
anti-gravity thing, you know.
Yeah, exactly. I haven't really dabbled with the anti-gravity stuff. I just more or less gravitated towards the energy side.
All right, Mike.
So
I'll catch
yeah.
you next week.
All right, man. Thanks for tuning in, everybody. Thanks, Mike, again, and we'll see everybody next week.
Take care, man.
Take care. Take care.